Hello, I'm Nobby Clark. Welcome to my workshop. I'm starting another little project on making an accessory for the milling machine. But before that, I just thought to talk a little bit about the drill chucks that I use on the milling machine. If this is going to be boring, just skip to the bit where I actually do a bit of machining work. But I hope you come along with me on this. Little talk. When I bought the milling machine, this is the chuck that came with it. It's obviously a key type chuck, and it's mounted with a Morse taper 3. Now the problem, because of the size of this, quite large and clunky, really, isn't it? But a lot of the projects that I do are quite small, and I use quite small drills, and when I use taps in the chuck, they're obviously quite small as well. This one takes drills. It's only shown in metric here, is from 3mm to 16mm, and a lot of the drills I use are smaller than 3mm, often 2 1.5 or even 1mm drills, and obviously they're not going to fit, and using smaller drill sizes, this is quite a big chuck to mount drills in and out of. Now if you've looked at any of my earlier videos, you may have noticed on the milling machine that I often use this very tiny drill chuck. Again, it's a key type. I'm not quite sure where this particular one came from. I think it was mounted on an odd accessory I bought, and I removed it and thought, well, that's going to be ideal to use for the very small drills. This tiny little chuck is a lot more handleable. This one, it's really nice actually. It's a British made Jacobs chuck. It's the size is 1A, and this will take drills from 0 basically up to 6.5mm or 1/4 of an inch. And I do use this a lot actually on the milling machine. It's mounted to start with on I think this is a Morse taper 2 and then a 2 to 3 adapter. The difference here is that when this one is used, obviously this is a lot heavier, you do use the drawbar that comes with the milling machine. The drawbar here has a 12mm thread. I'm sure you're all familiar with how drawbars work. They just screws from the top of the mill and just screws into here and pulls the Morse taper into position, and locking it in position as well, making it obviously very safe. With the adapter I've got here, I'm guessing there probably is an adapter that goes from this very tiny size here. I can't actually remember what the taper is. I think it's a J size taper, and there probably is an adapter that goes from here to Morse taper 3 that would take a drawbar, but I don't have one. So this one I just push into the Morse taper 3. I wind the jaws back and then very gently tap this back up into place, normally with a plastic mallet, just to push it into position. I've never had this one drop out of the Morse taper, which I guess is possibly a worry, but I've not had that problem with it, and I do like using this one. At a model engineering exhibition some time back, I found another one of these, and I bought that and mounted it onto a Morse taper 2, and I used that on my Myford lathe. Normally on the Myford lathe I use a keyless chuck, which takes drills in the same range as this one, 3 to 16 millimeters. But it's very convenient using a keyless chuck on the lathe, so you can make very quick drill changes. What I have occasionally used on the mill is a smaller keyless chuck. I bought this one because I'd previously bought one of these when I did some modifications to my bench drill. I didn't like using a keyless chuck on the bench drill. I just found it so fiddly to use, so I took that one off and mounted one of these onto it, which is absolutely fine. This keyless size, again, it's a B16 taper and takes drills from 1 millimeter to 13. So on the bench drill, that range of drills is not a problem at all. 1 mil would certainly be the smallest I'd ever use, really. And on the bench drill, I've never needed to use drills bigger than 13 millimeter on it. It's not very often I've had to drill anything any bigger than that. I have quite often on the lathe, but not on the mill. And well, I can't do that on the bench drill anyway. And what I use with this is, again, I've got another. I didn't have another Morse Taper 3 adapter for the drawbar for this one, so I have been using this one. Be careful not to jam that in the back. So I use that one, and again, like the small chuck, I just tap that into place. But it was a worry that as I'm going up in weight again, I mean, these keyless chucks are quite weighty. They are so nice to use because that they are very accurate as well. They grip the drills extremely well, and of course as you're turning and they grip, they gradually grip tighter as well. So it's a slight worry that this not being held in with the drawbar might be a problem. Comes to another thing here. A little while back I bought for the milling machine. Normally on the mill I use for almost everything else, I use a ER32 collet chuck with various ER32 collets. Most of the collets I've got are metric, and I have 2 or 3 imperial ones as well. But what I thought I'd try, I'd never tried this before, is using a Morse Taper 3 collet. And I bought one in 12 millimeter, which is the size that in end mills that I use a great deal for a lot of the work I do. And that has in the back of that collet, again, a 12 millimeter thread in the back for the drawbar. And I thought it may be perhaps possibly an idea of being able to use that into the collet chuck, because what I'd done in the past, I'd bought this adapter, again B16 end taper. This happens to be 1/2 inch, and I used to use that in this chuck. Being careful not to lock that in, so that I could pop this into the 12 millimeter collet on the ER32, and I did use that quite a bit, but haven't used that in fact for a little while. And it occurred to me perhaps I could use that in this chuck and then use it into the Morse Taper 3 collet. But when I was thinking about this, I'd completely forgotten that that was 12mm, and the collet that I had, sorry, that was 1/2 inch rather. It was a 1/2 inch, where the collet I had was 12mm. I'm getting it mixed up here. So 12mm on the collet, 1/2 inch. So when I was trying this out, I mounted that in there, and then of course discovered that that wouldn't go into the, obviously wouldn't go into the 12mm collet, and this wouldn't expand enough for that to fit. So I thought, well, let's try again. I bought myself another one of these, and a Morse Taper 3 collet with a 1/2 inch, and that's what this is actually. So of course that's going to fit fine into there. So that combination could quite happily be used into the milling machine. Obviously, by using that, I'm actually losing a bit of height here, but well, it doesn't matter if I'm using very small drills anyway. And it's another option to all of this lot as well. When the collet arrived, second problem, I discovered that with Morse Taper 3 metric collets, they do in fact take 12mm drawbars. The Imperial ones don't. They take 3/8 of an inch. So, well, no problem. That is the subject of my project here, making a 3/8 drawbar for the milling machine, and you'll see that following this, me making it. Now, going back in time, you see that this is what I'm making, and you see me making this is a 3/8 drawbar. So I found a piece of material the same diameter as this, and well, I brought that to length and then cut the 3/8 thread on here. So of course that's going to fit quite happily onto there. So that's the start of my drawbar. With the large drawbar, and I don't know, I couldn't quite see how this was manufactured here. I'm guessing that they started off with the larger diameter material, machine that down, put the 12mm thread on, and then mill the flats on the end here, so that you end up with this, if you like, a sort of a heavy duty, like a washer basically, that sits down on the top of the head of the mill, and that then pulls the Morse taper into position. I didn't really have much. I did have a bit of material this diameter, which is 20mm diameter, but I thought which wasn't actually long enough to machine this length out. And I thought, well, for me, using a bit of 20mm material and machining all that down seemed to be a bit of a waste. So with a bit of 20mm material I did have, I thought, well, I'll just make that collar, if that's what that's called, separately, and then what I can do is fit that on the end here, and what I'm going to do is pin that in place. As you see, this part has been made, but you'll see me making these bits, and then I can machine the flats on here in the milling machine, and I'll probably do that first and then pin that on in place. So, well, that a simple project, but I hope you sort of find that interesting. So that gives me another option of different drill chucks I can use. But one point on the drawbar, when the process of well, if we all know this, of removing this is when that's mounted in the mill is to grip this end and then use a spanner to undo this. I normally use a crescent wrench to do that. I keep this at the back of the mill so it's preset ready to go straight on the top there, and then unscrew that slightly, and then generally you tap the top of this just to drop the taper down. I mean, what I was using, which obviously is not good practice, I was just using a conventional hammer to do that, and of course in time that peens the top over. So what I did recently was file this back into shape again, just to make it look a little bit neater. But what I was using in the end was the hammer that has a brass end to it, so that I don't damage that too much when I'm tapping it. But what I managed to find recently is this. It's an ancient lead hammer. You can see that it's had a very, very hard life. One side is almost burred over. This one's not got very much meat left on it now. So I tend to use that, and of course the lead is obviously a lot more forgiving even than brass. I did look up, started looking for lead hammers. They are obviously still made, but they are, for what they are colossally expensive. I found this one just by chance on eBay, and I think this, including delivery, when I won an auction on it, I think it only cost me about £5, and there's going to be enough meat on that to last me out, I'm sure. But anyway, I thought I'd just share these and my thoughts on the drill chucks with you. But anyway, I'll stop nattering away now, and we'll get on with actually going back in time and making this again. So stick with me. Right, well the next job is to cut the flats on the end of this piece, the 4 flats. In the last sequence you saw me making this part, which will be the collar, which will fit here. Apologies here, while I was filming, when I drilled the hole out here and then sort of bored it to size, and then you probably saw me getting it set up to part this piece off. At that point I think I lost some of the footage somehow or other, so you didn't see that being parted off, but I don't suppose you're worried about that. I then put this part into the lathe chuck, just to face it off and give it a chamfer inside here as well. I think also around about that point of the video I lost focus as well. I didn't obviously notice that until I reviewed that little sequence, so again sorry about that. Anyway, the next job is to cut the flats. I'm going to do that first and then mount the collar on afterwards. Obviously there's lots of different ways of doing this. I only have one way of doing it now. It could be done if you had something like a dividing head. That could be mounted into the dividing head, into a sort of a collet or something, and then revolve it round to each side and cut it. I did for a short while have a dividing head. I was very kindly given one, but what I discovered was that really for my tiny mini mill it was just too big and heavy, and setting it up to cut work horizontally, because it was so big, it put the workpiece so high up that there wasn't really any room to get any tooling in. So sadly that was passed on to someone else. I do have just drag it over, a rotary table which I've used for quite a lot of different operations, but this one is set up primarily to use with a chuck on the top here. This came as 2 parts, the rotary table and this top plate, which has a threaded boss on here to take the chuck off the Myford lathe. But once this plate is removed, there isn't any through hole in it. It just has these T-slots here. There's 4 of them all round that go into the centre, so I can't use that. And putting the Myford lathe chuck on here, obviously there's not, well, there wouldn't be the depth to get this part through. Obviously this would be so much stick out that wouldn't work, so that's out. What I've done in the past is clamp a V block into the lathe chuck, into the milling machine chuck, and or vice rather, milling machine vice, and then mount the piece of material in the V block and clamp it down, then machine off one of the flats. Let's take that part out, and then turn it round and then use a set square up against the flat that I'd already cut to sort of level that up, and then cut the next one and so forth all the way around, and that worked fine. I've mostly cut flats in the past when I've been making chuck keys for the lathe. I've made a few of those actually, and that method works quite well. It's, you know, so it's not the ideal way of doing it, but it, you know, it does work. So that's another way of doing it. What I got myself a little while back was one of these devices. It's a square block that can be mounted into the the milling machine vise here, and mounted onto the front of it there's an ER32 collet chuck. So I'm going to use this. This is, you know, my sort of best method of doing it, I think. I've got a 12mm collet in here, which the part will slide into, so I can mount that up, leaving enough stick out. I've put a Sharpie mark on here. That's the sort of depth that I want to cut the flat. So that will be mounted into there, locked in place, and I can then use the what I've done beforehand, of course, is take some measurements here, work out roughly the size of the distance across the flats that I want. So it's only a matter of measuring the bar and deducting half the difference between the diameter here and the width across the two flats, and then I can machine that amount off each side as I turn it round. So that would be locked into the collet here, and that then can be clamped into the vise. And to get the same position every time, what you can do is just once that's all locked in tightly, is push that part, this collar, back against the end of the jaw here and lock that in place, so that once you've cut one, you can just turn it, bring it back again, and so forth all the way around, and that works fine. In time-honoured fashion, I've done a test as well. I thought this is best, you know, it's actually a piece of the same material that I used here. I just cleaned it up and faced it off, and then machined the flats all the way around, just as a test. This obviously needs a lot of deburring on that, just to get the rough edges off. But again, it's lots of operations that I do in the workshop. I like to run a test first, just to make sure everything's going to work out okay. The distance across here doesn't really matter too much, just to sort of make it look sort of neat in appearance, really. But then you just set the adjustable spanner to the size here. This will in fact be a little bit smaller than the drawbar that I've got in the milling machine at the moment, but it's not made for any specific spanner size. That doesn't really matter too much. I've drawn it so there's a little bit of an edge around here as well, just to make it look fairly neat. I worked it out that from the face here, I'm going down about 50 thousandths on each side, and I'm going to use the DRO to do this. It just means all I need to do is to touch off on the surface and then gradually come down to 50 thousandths all the way around. And once I've machined along on the first cut up to this line here, that's not important. I've made this about 10mm deep. Once I've reached that line, I can set the x-axis on the milling machine so that I bring the cutter along to the same position each time. Again, that's not got to be incredibly accurate, like just to keep it as neat as possible. So I'm going to set all this up and then sort of bring you back, just make a couple of cuts. So if I film the whole lot, it's going to take a long time to do that. So I think this for me is probably the best method of doing it. What I'm sort of looking into at the moment, I hope that perhaps at some time in the future, perhaps it's going to be around Christmas present time, I'm thinking of getting the device called a spin indexer. It does a similar job basically to a dividing head in a way, but is far less complicated to use. It comes with a similar sort of disc mounted on the front of it with a series of holes around it that you can register into, but those discs can be replaced with ones with specific numbers of holes to give you specific cuts on something. The good thing about the spin indexer is that the one I'm looking at, it takes a collet, but it takes a 5C collet. And the great thing about those is, of course, with that particular collet, the workpiece can be moved right the way through it as well. So if you've got a fairly long bar, that will go through there as well. So that was what I was perhaps going to go for in the future. But what I actually discovered, I didn't know this, that also available for the spin indexer, they do a collet, a special collet that has an ER32 chuck mounted on the end. So that would be ideal with that device. If you use the ER32 collet chuck on it as well, I don't have to buy any 5C collets. I can use all the collets that I've got with my ER32 system. The advantage also is that the 5C system does allow you to use larger diameter, I believe, than collets are available for this. So if I ever needed to machine any slightly larger diameter, I could then get the 5C collets to use in that as well. So that's a bit sort of a possibility for the future. Though I've got this one, this was actually the second one I bought. The first one I bought was the hexagonal one. I have that one as well, so you can make sort of hexagonal shapes around as well. I got that one basically because one of them came up on eBay brand new at a very, very good price, so I bought that, and I had to sort of wait a long time before the four-sided one came up also at a decent price as well. So I have got both of those now, so there's a lot of possibilities open to me to use this system as well, and of course, you know, working with my ER32 system as well. Anyway, I'm just going to stop filming for the moment while I set all this up, and then I'll bring you back. Right, well, here goes. So what I'm going to do, I'm going to bring the end mill down to touch off first. Then I can put a cut on and bring the end mill along to the line I've put on here. So, but that at this point, obviously I'll set the X position on the DRO, and when I touch off here, obviously I'll zero the Z axis as well, so that I can bring this down to the correct cut depth. Okay, well that's my first cut. Carefully clean off. Now it's just a matter of loosening the adapter here. Turn that round, bring it back against the vise, and lock that in place. Just give it a bit of a tap down and do the next side. What we'll do is just raise that up again. And then across. Okay, now bring it down to 0, which should give me level with the top of the work, and then we'll put a small cut on initially. And then bring the X along to the end of the cut as well. Again along to 0 in X. There we are, so that's the second cut. And what you probably noticed I forgot to do when I cut this one was to bring the cutter across in the Y direction to take the little corners out, but so I'll have to do that once I've got all the way around. I'll come back to this one just to do that. In my enthusiasm I just forgot that. Anyway, I'll carry on cutting the rest of those and bring you back when that's done, and then we'll just talk about fitting the little collar around the top of that. Well, I've completed the final two flats and where I'd forgot to bring the cutter across in the Y direction, I've done that as well. So the back of all these cuts will hopefully look the same all the way around. So I'll get the cutter right up out of harm's way again, and we can remove, actually before we remove the block, we can remove the wrong way around, that way. There we go. Can remove the workpiece. There we go. Take that out. So we've now got our flats all the way around with a sort of a reasonable join between them. Obviously I've got to go around this and deburr all the sharp edges all around that, but that's going to be fine. So next job will be to fit the collar, so that will come up to here, and I'm going to fit the collar in using roll pins. Now roll pins are something I've never used before, and I didn't have any. I did think of just drilling through this and just making a pin and driving it through, but I thought, well, you know, the neatest way of doing it would be to use a roll pin. I checked you know, what was available, but if you buy them as sort of a one-off size, if you like, that would be an expensive way to buy them. The best way is to buy them as a sort of a kit. I know these are probably not the highest quality you could possibly buy, but you can buy a set like this which has, I don't know how many different sizes. Obviously they go up to these humongous ones, which I don't suppose I'll ever use in my life, but it does have quite a lot of can you see? You can just about see that. I'll move that back slightly. It does have quite a lot of small sizes as well. And when a set like this is less than £7, I didn't think there was anywhere locally I could buy them, but then I did discover there was a local company that I could have bought these from. I've got these on mail order, but buying them locally, it would have sort of, I just added £1 to the price, which doesn't matter. So I'm going to find one which looks to be the ideal size. I may have to sort of cut it to length, and on the internet I downloaded details on roll pins, and there was a chart there giving you the correct drill sizes for the various diameters of these. So I suppose the slot in there is the amount that they would squeeze together. There is a sort of a guideline of measuring the roll pin, and I suppose on the diameter reducing that by a set number of thousandths to give you the correct drill size. But I'm going to have to do a bit of measuring up to see if I have a drill that's near enough the right size to make these work. And as with everything else, I'll do a test first just to make sure that's going to work okay. So at the point I'm going to do that, perhaps I'll bring you back and show you that bit as well, and that will obviously wind the project up then. So when I'm sort of ready to do that, I'll bring you back for that last part. The last job is to drill a hole through the collar, drill right the way through for the roll pin. I've already set this up using the DRO on my edge finder to find the centre here. And I'm using the collet block again to hold the material in place. Other option would be using the V block to hold this in the vise, but this will do the job probably better. I'm just going to, I've put a pointer in here and I'm just eyeballing the centre of this. That's accurate enough for this. So just remove this and put my little centering drill in. Put the drill in. The roll pin I'm using, as best I can judge it, it's a 2.5mm drill. Will give me a nice sort of pinch fit, I suppose you'd call it. Okay, that's through. I've drilled the hole all the way through, in the unlikely event that I'd ever need to take the roll pin out again. It's very unlikely I'd ever need to do that. Let's get the drill out. No, that way. Get the right way around in a minute. I was right the first time. Oh, that's it. A bit more. That's it. There we are, so we've got a hole all the way through there. I'll just deburr the sides of that and then we can drive the roll pin through. Right, this is the last stage, putting the roll pin in. Just hope this is the stage where things go horribly wrong. If I can get that started very carefully. Probably can't even see what I'm doing. Can you put my fingers in the way? Seems to have started okay. There we are. Just tap that in a little bit more. Great. So that's it basically. Is that in focus? Yeah, I think so. Yeah, just about. So basically that's completed. Next thing is just to give it a quick try and make sure it's going to work okay. Well, that's the end of my little project, making my 3/8 of an inch drawbar. That's the 12mm one that came with the milling machine. So let's give it a try. That pops in the top here, and that's my Morse Taper 3 Collet 4/2 inch. I'm going to use it with this. I've not got a chuck mounted on this, but this will, you know, just check that it is going to work okay. So that will push up into the taper here. Drawbar screws into the top. It's going to be a bit difficult to hold this to lock it up, but hopefully it's enough just to get that started, I hope. So not quite enough to lock it properly. I think once there's a chuck mounted on here, I've got something to hold on to. But that's it. So that will work fine. So it could be used with any 1/2 inch tooling. I've got 1/2 inch end mill or end mills. There's probably various other things that I've got that use a 1/2 inch arbor like this that could be used as well. See if I can get it out. So that would just wind out slightly, and then gently tap that. That's it, and that will then release the item from the collet. Obviously I can lock this in much tighter once I've got a chuck mounted on the end of it, but it will give you an idea of what's going on. So there we are, completed that little project. Sorry it was such a long video, but I hope you enjoyed the little journey of making that. So thanks for joining me in the workshop again, and thank you again to all the subscribers and commenters to my channel, and hope to have another video for you very, very soon. So bye bye for now.